My name's Steve Quern. I'm the creator of the File Child Project Man Spacecraft design concept. I was doing some research on the can you see that? Oh, there we go. To follow supplement more, April 1970. This is what NASA sent me when I requested information on the Apollo spacecraft program back in 1992 and 1993 time period when I was a member of the Planetary Society. And I decided to look at that data to work on the lunar lander for this project. This particular the File Chart Project concept, this is just a video graphics. Oops. I created a video recently. Ooh, what happened to you? Okay, everything, of course, is going to be scale 1. That means nothing. So what happened to you? Where'd you go? Move, -110, that's correct. So where you vanished? You're not linked to anything. So I am PRISMA3D is kind of wonky. Okay, so what I'm doing with it, this is basically a visual graphics. I might make a video of this. I got a video made talking about the File Child Project being 40 years old. And so I'm making this, I'm creating this for the visual graphics as a thumbnail for that video. Well, I may make a video of this to show the model. This is the File Chart Project model using the World War II dimensions, battleship dimensions. And so this is a more developed version of my previous models, other File Chart models. So I want to probably make a video of that. But right now, so this is going to be a File Child. This is the Apollo CSM LM. This is standard human value that I use for the File Chart Project theories, design theories. in version 2, I could reorganize these with relative ease. You just slide it and then move it down or move it up to where you want to go. With version 3, you're just going to have to make a copy and then delete the old one. Deck volume, no. This deck, okay, that is messed up. That needs to go. So we gotta go all the way down here to find the deck volume. Okay. Oh, that's the wrong one. That's the one I was wanting to do, so I can circle that. And then we go to scale. It's 111. Actually, it's 8 feet by 4 feet by 4 feet. Standard American residential lumber. Now this deck interior is this thing here. Nope. Get out of there. Get out of there. And we go over here, all the way to the top. The model hall. Let me hide that. And now go all the way down here. And interior volume. And then we go to residential volume. Wait a minute. That's the interior volume. Transparency volume should be oh, okay. Hide that. Okay. And then you go over here, go all the way to the top. Okay, the hall volume or the transparency volume. Unhide. And you got that mess. Okay. And then we go over here, get rid of that, go down here, interior volume, unhide that. Yeah, so you can do that. Okay. Things and things and things. Okay, so the numbers I've been using for the policy lunar module has been wrong. Okay, this I've been using the number 22 feet in diameter for the landing, the feet. I thought it was 22. I just looked at the more just a few minutes ago, and it's 31 feet in diameter. And so that's an error I've been using for decades. So yeah, I'm gonna have to redo this. And so the height, I have it for the, let's see here. Too far. No, that's the instrument unit. Portions of this I do not do. They got rid of. Okay, and there's the parachute section. That's not it. Yeah, this is the, wait. Yeah, this is the, yeah, so based on the schematics here, the overall length, okay, I use the landing mode dimensions. There's an antenna on top of the thing. From the feet, the bottom of the feet to the top, the highest point is the S-band antenna, which is 24 feet and something inches. And the top of the habitation section is actually 19 feet something inches. So I've been using 24 feet. And this is 24 feet. And the flower, and I did that for simplification because the habitation module is divided into 3 decks: the mission deck, the common deck, and the privacy deck. And I have all 3 decks at 8 feet. So the original habitation module design was 24 feet in height and 22 feet in diameter, which is wrong. It should be 31 feet in diameter. But that's the first design. The second design of the habitation model had 1 foot sections, frame sections between the decks. So you had an outer frame, a 1 foot outer frame by the mission deck and by the privacy deck, and then you had a 1 foot frame between the mission deck and a common deck, and a 1 foot frame between the common deck and the privacy deck. So the second generation habitation module was 24 plus 4, that's 28 feet, and then the 22 feet in diameter, and with a 20 feet interior, diameter interior. So I'm going to be changing that to 31 feet in diameter, external diameter, and 29 feet internal interior. But for the Apollo design, I'm going to switch it to 19 feet. Let's see here. There's the total. Yeah. Oh, actually it says 21 feet. But here it is, 19 feet, 10 inches, 10.65 inches. Actually, from the top of the foot to the top of the landing. So I don't know the exact measurements of the feet. I did some calculations with Blender 3D, and I took some ganders, took some liberties on that, and on some of my drawings, I just have a simplified single leg design to show where the legs were. Not an accurate representation, just a simplified process because I'm not an actual engineer, and I didn't want to take the time to mimic the pieces. It's really difficult. It's very complex. I just want to get the basic concept done, and that's what I'm basically doing. So my drawings are ultra simple, ultra simplistic. So yeah. So that has to be changed. So that's what I'm going to do. Okay. So let's see here. How are we going to do this? Following the volume. Can't modify that because the numbers don't stick. So I can't do the actual size, so I'm going to have to just delete the thing and just redo it. Model cylinder, transparent. Scale it. $19. Hey girl, that's Tezzy, she's... Okay. Move it. -50. And 700 for the time being to get there. What's going on? There we go. $29. Okay. That's not what I'm looking for. That's what I'm looking for. Wrong. Material that. There we go. .5. Okay, yeah, because it's an uneven number. There we go. Probably in the model body, in the module body. I gotta figure out what's going on with Tezzy. Again, the numbers don't stick, so I have to delete it and go with the numbers. So, again, I was thinking 13 feet, but it's going to be 15 feet in diameter. It's 14 feet, it's squarey. So, I'm going to go with 15 feet in diameter. And what is that again? The height number, oops. There's a lot that goes on to this. This is April 70, so I think this is the Apollo 13 mission. Here we go. I saw all the Apollo missions. The Apollo 1 fire. Okay, okay, we're looking at 9.3, 9.3. Okay, that's 14 and 11 inches. 15 feet and 5, 5, 22, 11, 23, okay. So 23 is 1. Nine, 11, 12, 13. So 16 and 2 inches. Something like that. Okay. 16 feet. Minimal body. No. The text is missing, so I got to redo the text. Delete that. Name. Follow. Mirror. Module volume. And then we go with a new model, cylinder. Yeah, this is stupid. This is why PRISMA3D is a 1-star app, as far as I'm concerned. It's got too many problems. Okay, rename that. Well, first of all, let's get its proper scale. 16 feet in length. And 15 feet in diameter. And then we're going to rotate that. And then we want to go there. I said minus 50. And then we go with 100, just see what's going on. 130. 131. There we go. Okay, so that's that. That's what this video is about, making that correction. Later.